Alright, today in this video we're going to go over our more energy conservation calculations. And so a 500 kilogram roller coaster car starts from rest at the top of a 60-meter hill. Find its kinetic energy when it's halfway down to the bottom. So before, just to first analyze this picture, if it's at rest, we know our kinetic energy at the top is 0, and our potential energy will be at its highest, whatever it is, which we're going to figure out in a little bit. And we know that at the very bottom, is going to have the least potential energy, which is 0. And we're going to have the most kinetic energy here. So let's figure out what B is, right? We're trying to figure out what's in the middle. So with our information, we can find gravitational potential energy, MGH. And we figure out that it's 294,000 joules. And if we just want to find out what it is at the halfway point, we just divide by 2. And we get 147,000 joules. Okay. So just like we said, the energy at the very top is potential. It's all potential, and then it converts to kinetic as it moves down the ramp. And at the very bottom, that's where it has the most kinetic energy. A 1 kilogram ball is tossed straight up with a kinetic energy of 196 joules. How high does it go? So the most important thing about when we're calculating problems like this is that you remember that Ke at the bottom is equal to Gp at the top. So they're kind of they're opposites at different points. So if we know our mass, and we know that Ke at the bottom and Gp at the top equal the same amount, then we can figure out height using the Gp formula. So our gravitational potential energy is 196 times 1 times 9.8 times h. We don't know what h is. So then we take 196 divided by 9.8 to figure out our height. Our height is 20 meters. An object 10 meters above the ground has 25 joules of gravitational potential energy. What is the mass of the object? If the object falls freely, how many joules of kinetic energy will it have gained when it is 5 meters above the ground? And finally, what will be its speed just before striking the ground? So let's figure out A. So what is the mass of the object? Using the gravitational potential energy formula, our Gp is 25. We don't know m. We know our G is 9.8, h is 10. So 9.8 times 10 is 98. So we take 25 divided by 98 to get m by itself, which is 0.26 kilograms. Now, if we're trying to find out the kinetic energy halfway, because at 5 meters is halfway, we know that if we just take half the gravitational potential energy, which will equal 12.5, because originally our potential energy was 25, so half would be 12.5. Okay, so what would be its speed just before striking the ground? So when we're dealing with speed, we're dealing with kinetic energy because it's moving. So GPE at the top equals KE at the bottom. We know our kinetic energy is 25. Our mass is 0.26. What is velocity? So we use the kinetic energy formula and we fill in our variables. Okay, we have 25 equals 1/2 0.26 v squared. So this right here, 1/2 0.26 squared is 0.13. Don't forget to put the 0.13 here. And that equals to 192.3. And so equals v squared. But to get rid of the square, we have to square root both sides. So v is equal to 13.87 meters per second. So how does friction play a part in the conservation of energy? Well, friction generates heat, which is a form of energy. So we see friction, like for example, when you rub your hands together when you're cold, you're creating that friction, and that's generating heat. So when energy is not completely conserved, it's usually lost to friction.